that there. Okay? So why don't you go ahead and take that, take a look at it. I want to go through a few problems and just talk about a few things. First thing, whenever I'm doing notes in here, I always put at the top our title. I mean, like if I'm filling out this note page and putting McCoy, my title is 1.1. That's the section in. Up here is parent functions. That is not the assignment. Like when you print off the assignment offline and if it has a title on it, your assignment is not this whole thing. Well, I have to do pages 3 through 10. No, dude, that's just the title. That's where it's located in the book. Okay? Parent functions and trans. Not chi. Okay, not chi. Okay? Section 1.1, I guess I could have put there. All right? I would always put the page numbers, pages 3 through 10. Just so you know to reference. These are the things we want to learn in this assignment. And then we have the example. I'm not going to actually graph that, but what parent function is that?
Absolute value.
Absolute value. Okay? How about that one?
Quadratic.
Quadratic. All right? How about that one?
Linear.
Linear. All right? How about that one? Quadratic. Tell your neighbor how you know that's quadratic. Square. Okay, here's what I want to talk to you about. Let's talk about how things are shifted. All right? When I have, and actually let me go back and use the bottom of this page. Let's say my function is called f of x. Some good notes to take down. Okay, if I want to actually shift that function, we know what linear is. Linear would mean it's x to the first power. Let's say I'm using a squared function or a cubic function or anything. I mean, maybe it's absolute value. Your grouping symbol and absolute value are your absolute value symbols. Okay? If I want to move this around, I'm going to talk about a few different types of shifts. I am going to deal with a negative, an a value, and we're going to do all this to our f of x function. So I'm going to put my x in there. And then I'm going to talk about something out here. So when I subtract in here and when I add or subtract out here. Okay? So let's say I actually want to take my f of x function and I want to shift it. Okay? I want to actually make it move 2 units to the right. That would become f of x minus 2. Now notice to the right is actually going that direction. Usually we would think of that as plus, right? But when you're dealing with a shift inside with x, it's always counterintuitive. That's called our h shift. It shifts to the right. So minus shifts to the right, plus shifts to the left. So maybe make a note of that. Minus goes that way when you're inside, and plus goes that way when you're inside those parentheses. Okay? So this is shifting 2 to the right. So I'm going to actually put that in down here as well. 2 to the right. All right? Well, I'm now going to shift that. After I shift it 2 to the right, I want to shift it 4 units up. So now I'd have no longer f of x minus 2 only. I'd have to say plus 4 at the end. That plus 4 is going to shift it 4 units up. Notice when it's shifting on the y-axis, it's going up or down, it's outside of parentheses. If it's going left or right, it's inside parentheses. Well, maybe now I want to say, you know what? Let's make this a quadratic function. We're going to put the x squared there. Okay. Oops, that's not what it's... there. Okay. So we're going to make this a quadratic function. All right. And now I'm saying that this is too fat of a quadratic function. It needs to go on a diet. I need to make it narrower. That's controlled by your a term. Your a term controls the width. Okay, it tells you how fast something is approaching infinity. or negative infinity. Okay? I like to think of it as our accelerator. It makes it usually wide or narrow. It makes it or rise up faster or run up fast, or rise faster or slower. Okay? And a negative symbol always, anyone know? Negative symbol flips it. Okay? It flips your graph. Now the negative out here flips it over the x-axis. If the negative shows up inside here, which is a very confusing piece, it flips it over y. So we'll talk about that later. All right. That is a lot of stuff, man. Where this 2 is, we usually call that value h. Where this 4 is, we usually call that value k. So when you're all said and done, it's negative a times f of x minus h. And if we're dealing with, we'll just leave it like that for now. We won't worry about quadratic, plus k. And there's actually other stuff that happen in here that we'll talk about at a later time. Okay. Questions? All right. So with that being said, what I want you to do is I want you to tell your neighbor what happens, with those functions right there. How do they shift? Okay, what happens with this one? Good, it moves up 3. It's moving up on the y-axis 3. Why? Why doesn't it move on the x-axis? What would we have to see for it to move on x? Parentheses. No parentheses, so it's not moving on x. How about here? It's moving right 2. This is a horizontal shift because it's happening inside parentheses with x. Okay? This is vertical because it's happening outside of parentheses. Okay? What's happening here? Really, all it is flipping over the x-axis. Okay, so if I was to graph them that look like that. Let's use this grid paper here. Okay, let's say I was taking the absolute value of x. So number 4 was absolute value of negative x. Or, excuse me, the negative absolute value of x. So if I have the absolute value of x, that normal graph kind of looks like, well, it doesn't kind of, it looks like this. Okay, it has a slope of 1 because the number in front of it is 1. If I'm doing f of x equals the absolute value of x. The a term out in front here is a 1. That means I rise 1, run 1. Slope of 1 going in, slope of 1 coming out. Okay, there we got it. Guess it's negative 1 going in, positive 1 going out. But yes? Well, this is the parent function. So you're right. This one right here, when I graph this one, it would flip over that. Right, so this top one, I've just graphed the parent function, f of x equals x, or equals the absolute value of x. The n of x is this one I'm doing in blue here. Okay, so if I was labeling these, this one would be n. We call this one up here f. Okay, so it's just reflected over. Let's say I wanted to graph. Any questions on that one? Let's say I wanted to graph, say, like number 3. Number 3, I would be dealing with the original parabola would be, let me use a different piece of paper here. Let's use this grid. let's say I have f of x equals x squared. And my shift is this this h of x here. So f of x equals x squared, the vertex is at 0, 0. And what's my a term here? What's in front of the x squared? 1. That means when I go over 1, I go up 1. That's always true in a parabola. You'll always go over 1 and up, however, whatever your a is. To find out what you have to do when you go over 2, well, you have to plug the 2 in for x. When I put 2 in for x, I get 4. 1, 2, 3, 4. Okay, and 3 would give me 9, and so on. All right, so I have my parabola there. I graph it. Well, this is saying I'm taking that exact parabola. Notice a is still 1. I'm taking my graph of f, which I'm having a hard time labeling f there. Okay. I take my graph of f and I shift it right 2 units. So I take and slide each point over 2 units. To there, to there, to there, and to there. And this point goes to there, and to there. And kerch out. Everyone rate themselves 1 to 5. 5, you got it. 1, you're struggling. Okay, some of you are still taking down notes. I'll give you a minute to get caught up there. Remember to label this one H, so you know the difference between the two. Label it H because of H of X there. All right, so I'm going to do one more with you. Here it is. Let's see if you can do it, and I'm going to have you do it while I'm handing out today's assignment. Here's your ultimate challenge. I want you to graph y equals -2. Actually, let's make that -1/2. -1/2, absolute value of x plus 2 minus 4. All minus 4. All right, go for it. All right. Hey, let's see. So usually our vertex starts at 0, 0. Are we shifting left or right? Yeah, we're shifting to the left 2, right? 2. We're shifting to the left 2 because there's implied parentheses there. So 1, 2. Are we going up or down? Yeah, left 2 here, and down 4. Okay, 1, 2, 3, 4, and then this out here, the negative tells us it goes downward, and this is like your slope. So we go over 1, our slope is 1/2, right? We rise 1, we run 2. Okay, rise 1, run 2. Rise 1, run 2. So the further or the closer to 0 you get, the wider your graph gets. The further away from 0 you get, the narrower your graph gets. And that would end up being the graph. That's the graph of y. Any questions? So this flips. This controls kind of your accelerator, if you think of it that way. How fast or slow you're going to infinity. Or negative infinity in this case. All right, your assignment. Right here. Now, it looks like a lot of writing. It's not quite as bad as it looks. You're not doing really any graphing. You are matching the description to each of the graphs. Oh, one last thing. Sorry. I forgot this last period too. Guys, when a out here is less than 1, that is called a shrink. That is called a vertical shrink. Okay, when it's greater than 1, so if that was like 3 times x plus 2 minus 4. This would be called a vertical stretch. All right, that'll help you there. Any questions? Yes. You do not have to turn in the student journal stuff. It just means it's sometimes we do it, sometimes we don't. That's okay. Any other questions? All right, Chromebooks put away, please. You got your assignment. Remember to go online and print me assignment. Print that print me assignment. It's only 3 short problems. Okay? Someone tell Scarlett what I'm talking about.
Or you can send a text for
Okay. What's that?
Can you send a text